This one definitely looks a bit meatier. We have Z here in cis format, or it's length 1 and angle theta. Z is not equal to 1. So okay, we can't have that. So again, it means that if it's not 1, that can't be 0. Cosine theta is 0 means that theta is pi. And we can't have that as, so that can't be 0 either. So now show that the real part of this is 0. So we need to work out what 1 plus z over 1 subtract z is. That's 1 plus cosine theta plus I sine theta over 1 subtract cosine theta subtract I sine theta. That's what z equals. No, that's what 1 plus z over 1 subtract z equals. And this isn't much use because we've got an imaginary number on the denominator, so I can't know which is real bit and which is the imaginary bit. So to get rid of the imaginary bit on the denominator, we need to multiply numerator and denominator by the complex conjugate. So 1 subtract cosine theta, change the sign of the imaginary part, and the same on the numerator. And multiplying those out is going to be horrible, so let's do a nice little grid. 1 cosine theta I sine theta, and 1 negative cosine theta and I sine theta. So 1 cosine theta I sine theta. This is negative cosine theta, negative cosine squared theta, and negative I sine theta cosine theta. I sine theta, I sine theta cosine theta, and I squared sine theta is negative sine squared theta. So it's nice because those two cancel, those two cancel. So we get on the numerator, we get 1 plus 2I sine theta, subtract cosine squared theta, subtract sine squared theta, over, let's try the denominator, which should come out nicely because we used a complex conjugate pair. 1 negative cosine theta, let's give ourselves a bit more space, 1 negative cosine theta and negative I sine theta, 1 negative cosine theta, I sine theta, 1 negative cosine theta, negative I sine theta, negative cosine theta, cosine squared theta, I sine theta, cosine theta, I sine theta, negative I sine theta, cosine theta, and negative I squared makes it positive sine squared theta. So it's over, this should cancel, this cancels, as expected all the imaginary parts cancel to give us 1 subtract 2 cosine theta plus sine squared theta plus cosine squared. So we've now got yes, 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 yes. We've got everything we need. Actually, this doesn't look bad because that's a negative of sine squared theta plus cosine squared theta. So we get 1 plus 2I sine theta, subtract brackets sine squared theta plus cosine squared theta, over 1 subtract 2 cosine theta. Oh, look, we've got a sine squared theta plus cosine squared theta, which is 1, plus 1. So that equals 1 plus 2I sine theta, subtract 1, over 2 subtract 2 cosine theta, which equals, the 1's cancel, 2I sine theta, over 2 subtract 2 cosine theta. And the real part of 2I sine theta over 2 subtract 2 cosine theta, well, given it's, look here, it's all imaginary, some other number around it, must be 0. Thus it is demonstrated, quod erat demonstrandum.